Hello everybody. We're working on chapter 21, section 1, magnetism. With today's lesson, we'll learn a little bit about magnets and we will try to explain some of the bigger factors that I see in the chapter. Alright, so magnetism. You can see there's always a north and a south pole, and the opposites will attract. If they're like, they will repel. Alright, with a pole, this is like we had where we can see the magnetic field lines. These field lines will connect from one to the other, and you can make this design if you have lead shards. They always have two poles, magnets do, a north and a south. Even if I were to cut that in half, there would be a south here, there would be a north here on the two smaller magnets. It will always be that way. You can see the two poles, we point them out there. Now, this shows where if we have two opposite charges, they will attract. The two unlike poles attract together. Oops. All right. Now, if we have two like poles, they will repel. We've known that for a while. This is just a way of showing what the field lines look like and that force that's there that causes it to push or turn away. We see the same items here, and you can see how the items line up across since those poles are opposite. If you cut the magnet in half, how many north poles and how many south poles will you have? Well, it's two of each. Now, magnetic fields are a little bit harder to understand. It's how the force of a magnet is exerted. All right. To repel, you see that magnet floating there. Let me get the lights real quick. Here, we have the same thing. These like ones repel, and it actually can hold up items or other things. Some of you may think of the monorail or other items like that, electrically or electromagnetically held in the air. Alright? Like ones repel. See the red and the red, the blue and the blue? Those are like charges. Now, if the forces are opposite, they will attract and will be hard to pull apart. The magnetic field is strongest where? Where do you think? Location A, location B, location C, or location D? D and C are nearest the poles. That's where we have the strongest charge, where it will be most attracted. Making magnetic fields. You can magnetize iron or steel. Unmagnetized metals have particles that are in all different directions. These domains align in all directions when you run a magnetized item over it or electricity through it. And all the arrows will line up. You can see page 616, item A. By aligning their domains, 616B, all of them will point in one direction, and you'll have a north pole and a south pole, or a north pole and a south pole, and therefore you can magnetize them. You may have seen this before. If you've got a current throwing through a iron item or another item that can be magnetized, the result is a newly magnetized metal with all the electrons pointing, all the items pointing in one direction. There's page 616C. Now, what causes magnetic fields? A moving electric charge going in one direction. If that is from a battery, we know batteries go from negative to positive, so all the charges are moving in one direction, causing all the particles to line up. Now, Earth's magnetic field. We are always spinning in one direction. We have a magnetic north, which is a little bit different than our actual north. All right? Earth's magnetic field deflects most of the sun's charged particles. So there's a purpose, there's a reason that God created the earth this way with a magnetic field, and it was to protect us from the harmful rays of the sun. An image like this can show what we're seeing. You may have seen this, you can see it in the book. The magnetic field and many other items that protect us are amazing designs. If you watch One Strange Rock on Netflix, Will Smith is the commentator. You will see many of these things, and they have astronauts that explain it. It's an interesting show to me, a science person. Helps migrating animals. This allows them to know which way to go. When these large migrations happen, talks about daylight times, but there's also magnetic items in their memory that help them remember where to go. Controls compasses, which allow us to know where we're going. The needle always aligns with the Earth's north pole. All right? Therefore, allowing us to know what direction is north and orienting ourselves. And that's all we have today. Thank you so much, guys and gals.